Is the sound clear and loud? Do I need to increase my microphone volume?
Clear.
Clear. Okay. Sebelum ni you orang ada kelas tak?
Saya ada.
Before 11 ada kelas?
Ada.
Ada.
Safety.
Apa kelas? Apa subjek tu?
Safety management.
For safety management. So it means all of you are already very tired lah.
I'm okay.
Okay. So we start. Okay, on Monday, I've already covered the chapter on Introduction to PPC. So you should know what is PPC now. So today we are moving into another chapter which is called forecasting. Okay, there are many things that we can forecast. Okay, but the focus of PPC is to forecast customer demand. Okay, and forecasting is normally one of the earlier chapters, or the beginning chapters that you will learn in PPC. Okay, the reason is because we cannot really start production if we do not know the customer demand. Okay, even if we know the customer demand, we also need to know what is the exact quantity of the demand. Okay, so this is where forecasting becomes important. And normally company will do forecasting first, then only they will do their capacity planning, their materials requirement planning, their scheduling and so forth in order to start the production. Okay, let me put a slideshow. Right, so if you look at the slides, I already uploaded to e-learning. Okay, I already uploaded to e-learning. It's about 90 over slides, about 100 slides. So the beginning portion of the slides are more on the theories, okay, the concepts and things like that. Okay, so maybe the first hour of this class, you have to bear with me. There are some theories that I need to explain to you first before we can go into the mathematical models. Okay, so first thing, what is forecasting? Forecasting is the process of predicting a future event. Right, so if you look at this picture here, I think it will explain everything. This picture here shows there's a wizard, sorcerer, or bomber looking at the magic ball, trying to predict something for this guy on the right side. So that is prediction, okay, or forecasting, trying to predict something. But of course, engineers do not do this. You as an engineer do not predict things like this. You should predict or forecast things based on data. Okay, based on real or actual data. This is what you should do. Now, forecasting is very important because it forms the underlying basis for all kinds of business decisions. Okay, such as production, inventory, personnel, and facilities. Okay, so imagine if you do not know the customer demand, then companies will have a hard time setting their production quantity because they do not know what and how many units the customer wants. Okay, so forecasting affects production, also affects inventory. Okay, if we do not know customer demand, then it will be difficult for companies to decide how many inventory to keep in the warehouse. Okay, same for personnel and facilities. So forecasting affect personnel. It will influence the number of personnel that the company have to hire. Okay, personnel means workers, operators. It will affect also the facilities. Okay, especially the number and type of facilities that the company should have. Forecasting can be categorized based on time horizon. Okay, you can have short range forecast, medium range forecast, and long range forecast. Short range forecast is normally less than 3 months. Right, generally used to forecast items related to chasing, job scheduling, workforce levels, okay, things that you have to do on a frequent basis. Okay, and medium range forecast is normally within 3 months to 3 years and used to forecast items related to sales, financial budgeting, and so forth. And long range forecast is normally for more than 3 years. Okay, for example, forecasting new product planning. Okay, forecasting whether we need to launch a new product or not. Okay, forecasting about facility location, where we should start a new factory, and also activities related to research and development. Another thing you need to understand is this, the influence of forecasting on product life cycle. So let me talk a little bit on product life cycle so that everyone understands. Now, every product will go through this life cycle. Okay, starting with introduction, growth, then maturity, and then decline. Look at this diagram. Okay, we have 4 phases here: introduction, growth, maturity, decline. So every product will follow a curve like this, moving from one phase to another phase. Okay, so normally when we start to launch a product, we will begin here. Okay, so at this moment, we'll find that customer demand is still near to zero, and then it will slowly pick up, right? It will slowly pick up, and then it will enter the growth phase. So at the growth phase, the demand for the product will actually shoot up because it's growing. Okay, it will continue to go up until it reaches the maturity phase. Okay, maturity phase is where the product becomes mature. Okay, where a lot of people are already using it. Technology become mature. So the demand for the product during the maturity phase will actually peak. It will peak, it will reach the peak point, and then it will tend to stable down. Okay, once it is stable down, then it will start to go down, where it will enter the decline phase. Okay, in the decline phase, the demand for the product will go down. Okay, slowly the product will become obsolete, and later it will die down. Okay, once it die down, the product will virtually disappear from the market. So at that time, it means that you can only find the product in the museum, right? So look at some examples of products. For example, electric vehicles. Okay, we have seen electric vehicles in the market. Companies have already launched electric vehicles several years ago. Okay, in the US, Tesla is making a lot of electric vehicles. Okay, in China, we have a company called Evergrande, which is also launching a lot of electric vehicles. Okay, but the demand for electric vehicle is still picking up. For example, in Malaysia, it's still not very common. In Singapore, it's more common. You see, in Singapore, there are more charging points. But in Malaysia, I don't see any at the moment. Right? So electric vehicle is at this stage here, between introduction and growing stage. Okay, and another example, for example, DVDs. DVDs are already in the decline phase. Okay, but of course, before that, DVD has started from here, went through the growth stage, become mature, but currently it is in the decline phase. Okay, nowadays nobody use DVDs anymore. Even if you buy laptops or computers, they do not have DVD driver. Okay, and same with analog TVs. You know analog TVs, Analog TVs are those big TVs with a big cathode ray tube, like a box, refrigerator box. But nowadays nobody use analog TVs. It's dying down soon. It's going to disappear from the market because nowadays we are using flat screen TV, plasma TV, LED, LCD, and so. Okay, why do you have to understand this product life cycle? It's because it has impact on forecasting. Um, the thing is this: if we are in the if we are in the introduction and growth stage, okay, let's say a product is in the introduction and growth stage, then it will require more accurate and longer forecast. Because why? Because the product is growing, demand is still uncertain, okay, and demand can shoot up, okay, anytime, it can fluctuate. So whenever a product is in the introduction phase or growth phase, we need to do forecasts more accurately, and longer forecasts are actually required. Okay, because the growing stage, introduction stage, is normally longer than maturity phase and also the decline phase. But if the product is really in the maturity and decline phase, then it means that forecast is no longer important, right? Because in the maturity phase, the product demand has already stable down. Okay, you see it's stable down, it has peaked and it has stable down. So forecast is not so important anymore. And if the product has entered the decline phase, then it means that okay, forecasting is even not important. Why? Because nobody is buying the product anymore. The product is going to die down and disappear from the market. Right? So I hope you understand the impact of this product life cycle on forecasting. You can read all this. I don't want to go through all this. Right? Now, forecasting can also be categorized based on economic forecast, technological forecast, demand forecast. Economic forecast is about forecasting what? Forecasting items related to economy. Okay, for example, forecasting the inflation rate. Okay, forecasting the currency exchange rate. Okay, forecasting what? Housing prices. Okay, rental rates. These are all economic forecasting. In addition to economic forecasting, we can also have technological forecasting. So technological forecasting is more on forecasting the success rate or failure rate of technology. Okay, or forecasting the progression rate of the technology, and even about forecasting the impact of the technology. And the third category is demand forecast. This is our focus. So this chapter that you will learn later, all the pages that will come are all about demand forecasting. Okay, what is demand forecasting? It means forecasting the sales or demand of products and services. Whenever we say demand or sales, actually they mean the same thing. When we say we want to forecast demand, okay, we want to forecast sales, they mean the same thing. Okay, they are normally used interchangeably, so please understand. Exam question, is it demand, sales? They're actually the same thing. So, what is the strategic importance of forecasting? Okay, strategic importance. It has strategic importance for supply chain management. Okay, supply chain consists of what? Consists of suppliers, right? As suppliers from the supplier, it would deliver the raw materials to the manufacturer. Manufacturer will manufacture the product. After that, the product will be sent to either the distributor, okay, or the retailer. After that, the retailer will then sell the product. Eventually, it will reach the customer. Okay, this whole thing is known as supply chain. So this is a chain from supplier to manufacturer to distributor, retailer, and finally the customer. Okay, so imagine if we do not know the customer demand, then what will happen? It will affect everyone. It will affect all the distributor, retailer, manufacturer, and supplier in the whole supply chain. Right? Once we do not know this, the whole chain will be affected. So therefore, it has a very strategic importance to supply chain management. And forecasting also has great importance on human resource management. Okay, if we know the customer demand accurately, then it will help human resource managers to hire the right number of employees or even lay off the unnecessary employees. And thirdly, it also has significant importance on capacity planning. Okay, we can plan our capacity accurately if we know customer demand accurately. Right? Okay, next steps in doing forecasting. The first two steps. Okay, if I don't put slideshow, can you all see clearly?
Yes, yes, sir.
You can still see clearly, yeah?
Yes, yes.
Okay, I think better like this. Now, the first two steps, actually, you don't have to do it. Determine the use of the forecast, select the items to be forecasted. Okay, I already explained this. The items to be forecasted are actually the customer demand. Okay, so the steps that you have to know is actually starting from step 3 until step 7, where you have to determine the time horizon of the forecast. Okay, and then you have to select the forecasting models that you want to use. Later, I will go into more detail about the different types of models that you can use. Now, before you can forecast, you need data. Okay, so therefore you have to gather the data, collect the data needed to make the forecast. But of course, in exam, in tests, data will be given. But in practice, you have to collect the data. Once you have the data, once you have selected the model to use, then you can make the forecast. You can calculate the forecast. Right, and the last step, normally people will validate the forecast and implement the result. Okay, validate means verifying how accurate is the forecast. So how to verify the accuracy of the forecast? Normally we calculate the errors. Okay, later I'll come to that. We'll calculate the errors, and then if the errors is acceptable, then we can actually implement the results. Means we can follow the forecast. Realities that you have to know: forecasts are seldom perfect. In fact, it's not perfect at all. Okay, why? Because there are many unpredictable external factors that can impact on our forecast. Okay, and most techniques that you learn in the class assume a certain degree of stability in the system. Okay, meaning that we assume that whatever we forecast is quite stable, it's not affected by other factors such as political factors, economic factors, and social factors. Right, forecasting approaches. You can use qualitative methods. You can also use quantitative methods. Right, qualitative methods basically is the simplest. Okay, what you do is you just use your intuition, your experience, your gut feeling, and just forecast. Okay, as simple as that. That is qualitative method. So basically, it's based on opinions. Okay, based on opinion, and it's used when the situation is not clear. Normally, it's used when the situation is not clear, is vague, and where little data exists. Quantitative method is different. Quantitative methods always involve the use of mathematical techniques. Okay, meaning you need to use some formulas, some mathematical models in order for you to do the forecast. And quantitative method is normally used when the situation is more stable and when historical data exists. Okay, I already said you cannot do forecasting if you do not have data. If you do not have data, then the best you can do is you use qualitative methods and you predict based on your intuition. Right, let's discuss more on the types of qualitative methods. There are 4 different types of qualitative methods in the textbook. First is called jury of executive opinions, means a pool or panel of expert opinions. Second, you can use Delphi method. Third, you can use what we call sales force composite. Fourth is called market survey. Okay, first method, uh, jury of executive opinion means you pull together a group of experts, okay, and the expert give their opinions to make the forecast. Okay, that is jury of executive opinion. Delphi method is also like the first method. You need a group of experts, but the experts will be queried iteratively. Will be asked iteratively until final consensus is reached. That is Delphi method. Salesforce composite means we ask salespersons to do the forecast. Okay, so instead of asking customers, we ask the salesperson or salesman, okay, to project what is their sales. So their sales projection becomes the forecast. That is Salesforce composite. Okay, and fourth is market survey. Market survey means we ask the customers, we ask the customers directly, find out their demands. Right, so these are the details of the first method. Jury of executive opinion, as already said, executive here means experts. Okay, so it will involve a group of high-level experts or managers. So this group of managers or executive, they will sit down together and they will give their opinions, forecast the demand. So the group will estimate the demand by working together. Huh? Simple, right? Nothing difficult. Okay, Delphi method, as I said, is also like the first method, but it's a more iterative process. Huh? Okay, the thing will continue until consensus is reached. Okay, so for example, you started the Delphi method, you ask the experts to forecast the demand. Okay, and then the experts return their forecast, you look at it. Okay, are all the forecasts the same? Okay, did all the respondents or experts give the same values? If no, then you repeat the process again. You move to the second round. Okay, you ask the experts to forecast again. Okay, you tell them that there are differences in your values. Okay, please forecast again. So the experts will forecast again and return their value. You look at the values again. If they're still different, then you repeat again. You iterate the process. You return back to the experts. You ask the experts to do it again. Okay, until a final consensus is reached, until all the experts agreed on a single value. So that is called Delphi method. So it's an iterative process. It will continue until consensus is reached. Salesforce composite, I already said, this is where each salesperson will project his or her sales. So it means we don't go and ask the customers, we ask the salesperson. Okay, because salespersons are the one that sells the thing to the customers. So we assume that salesperson knows the customers very well. Okay, so we ask the salesperson to actually project his or her sales. Okay, asking the salesperson to predict how much you're able to sell. So each salesperson will project his or her sales, and then we combine all those values, we aggregate them. Okay, we combine them either at the district level or national level. Okay, so for example, or organization level. Okay, if let's say an organization have 50 salesperson, so we'll just aggregate it, combine it at the organizational level, and that final aggregated value is the forecast value. So that is Salesforce composite. And market survey, this is also easy. It means we just ask customers. Okay, we ask customers how many units you required. Okay, and that become our forecast, right? But the problem is sometimes what customer says and what they actually do may be different. They may say that they need the product, but eventually they don't buy the product. So what customer says may not be may be different from what they want. Right. So these are quantitative approaches that you will learn. Quantitative approaches, we have 5 types. You need to know all the 5 types. First is naive approach. This is easiest. Moving averages, exponential smoothing, trend projection, linear regression. The first 4 techniques is known as time series models, and the last technique is called associative model. Okay, so now we are going into the quantitative model. I already completed all this qualitative method. Our focus should be on this quantitative models. Right, so let's look at the time series model first. Time series models consist of naive approach, moving average, exponential smoothing, and trend projection. Now, in time series model, first thing you have to know or remember is, okay, it uses a set of evenly spaced numerical data. Okay, what is the meaning of evenly spaced numerical data? Evenly spaced, So it means that if your data is on an hourly basis, then your data has to be hourly. Okay, it means every hour you need data. Okay, if you're using weekly data, then all the data has to be weekly. If you are using monthly data, then all your data has to be monthly. Understand? If you're using yearly data, then every year you have to collect data on a yearly basis. Okay, we cannot have hourly data mixed with weekly data, mixed with monthly data, and do the forecasting. Okay, it cannot be done like this. Okay, because all the data has to be evenly spaced. Hope you understand. So it means that data has to be obtained at regular time periods. If hour, then every hour. Week, every week. If month, every month. Right? And this type of forecast is only based on past values. No other variables are considered important. So it means that we try to forecast future demand, okay, entirely based on past demand. Okay, we don't consider other factors, okay, like customer requirement, like political factors, social factors, environmental factors, and so forth. Okay, so we are not saying that certain inputs will affect the demand. We don't consider all the inputs or factors. Okay, we only forecast the demand based on previous past demands, right? Because we assume that factors influencing past and present will continue to influence in the future. That's why we rely everything on previous data, because we believe everything that influences past and present will continue to influence the future. Hope it's clear, huh? Before we go into more detail of all these approaches, okay, you need to understand these four things first. These are the behavior, the pattern, the behavior of demand. It's a component of time series. Okay, the behavior or the pattern could be trend, could be cyclical, could be seasonal, could be random. Right? So if you look at this diagram, this this blue line here, the light blue. Okay, let's say this is the actual demand. So you see, actual demand can fluctuate. Okay, by the way, x-axis is time, years. Y-axis is the demand. So demand can fluctuate. Okay, but the demand is increasing, right? So if you look at the dark blue line, I think it's increasing. So this is called a trend, basically. Okay, and you see that after a certain period, the demand will peak. Okay, there's a peak point here, peak point here, peak point here, peak point here. So this is called seasonal. Okay, and demand also show a cycle pattern, right? A cyclical pattern. Goes up, down, and then up, down, up, down. This is called cyclical. And then if you zoom inside the blue line, the light blue line, you see there's random fluctuation, right? So that is called random. Right? So trend component, it means you have a persistent either upwards or downwards pattern. Okay, so if you have something like this, then this is a trend. The demand is going down. Okay, so trend of demand happens due to many factors. Okay, for example, due to population change, due to technology change, due to aging, due to culture, and so forth. Seasonal is another pattern, okay, of behavior of demand. Seasonal means that there's a regular pattern of up and down fluctuation. Okay, it's just like cyclical. You have a regular pattern of up and then down, and then up and then down. Okay, and seasonal behavior normally is due to weather, due to weather condition, due to customs, etc. For example, in Western country in the northern hemisphere during winter, winter starts December, January, February, in northern hemisphere. So during winter, the demand for winter clothing will increase. Okay, so it will peak. Okay, and during summer, of course, the demand for summer clothing will increase. Okay, so there's a seasonal demand for winter clothing and summer clothing. right? Now, not only weather, also sometimes affected by custom, custom. Okay, for example, in Malaysia, Indonesia during Raya, okay, or during Deepavali, during Chinese New Year, demand for clothing will also increase because people tend to wear new clothes, okay, during all these festive seasons. Okay, or next week Ramadan is coming, right? So when Ramadan is coming, I think the demand for what? For kurma, buah kurma. Okay, for dates. Buah kurma is dates, right? So the demand for buah kurma will increase during Ramadan month. So that is actually customs, Okay, and seasonal behavior normally occurs within a single year, a single year. So the peak will happen within a single year, not multiple years. So that is the difference with cyclical pattern. Okay, cyclical pattern is also like seasonal. It has repeating up and down movements. Okay, it will go up, it will go down, it will go up and go down, but it could be in multiple years duration. Okay, look at this. The first peak occurs after 4 years, and then second peak occurs after another, maybe 5 or 6 years. Okay, just like the financial crisis, if you remember. Okay, anyone knows when the first Asian financial crisis happened?
1998.
Right. Yeah, somewhere around there, 1998, 1997. Are you born at that year?
Yes. Yes.
Born already,
Yeah.
Huh? No, some not born yet.
Already.
Maybe some are just born, I don't know, Because you are, what, you are now 20 years old, 19 years old? Okay, so the first financial crisis happens 1998. Okay, and this financial crisis, look at the pattern, it is actually cyclical, cyclical, okay? And when did the second financial crisis happen? Around 2008, So it's around 10 years from 1998, right? 2008, you have the second financial crisis. And then, do we have the third crisis? Yes, we just had it, right? During the start of COVID-19, 2020. Okay, in 2020, most of the share market drops or the share price drop. Okay, inflation happens. So that happens after also about 10 to 12 years. Okay, first financial crisis 1988, second financial crisis 2008, third financial crisis 2020. Right? So that is what we call a cyclical component. It happens in multiple years duration. And the last pattern is called random. This is random. You look at the graph, it's random. Random fluctuation, up, down, up, down. Okay, so it's erratic, it's unsystematic, it's stochastic. That is random. Okay, it happens because this is the natural behavior of demand. It's due to random variation or unforeseen events. Okay, just like quality, you learn quality. Okay, you have assignable costs, you have unassignable costs. Okay, because of all this. Okay, so let's move on. Let's move on to the real thing. Okay, one question in the chat. Okay, 1999. Yeah, I think 1999, 1999, 1998, 97, I don't remember. It's around that time. Okay, Iswara asked a question. Is our current world situation categorized as random component number? What do you mean by current world situation? There's so many current world situations. Okay, Alpha? What do you mean by current world situation?
An example, doctor, the current situation includes the war, COVID, because uh, I thought at first that the war is categorized in the time component before that you explained, but after you explained about the random uh, component, I think it's categorized as that. Is that correct or no, Doctor? Because first of all, it is completely unforeseen, and we could have not predicted, and the impact of that situation uh, is very big to us, even though we are in the opposite side of the world.
Yeah. Okay. Okay. I agree with you. Okay, but if you really study, the war between you're talking about the war, right, between Ukraine and Russia, right? There are different school of thoughts why the war started. Okay, some say it's because of Russia, some say it's because of the West. Okay, so it's up to you which school of thoughts, which perspective you want to accept now. Okay, Hafizam say COVID maybe, yeah, okay, COVID is random lah, okay, nowadays. Okay, if you look at the random fluctuation of COVID, daily cases, okay, it's random, sometimes go up, sometimes go down. Okay, so that is just patterns, behaviors of demand, customer demands. Okay, now we go into the real thing. Okay, we look at the technical approach, the time series approach, the quantitative approach that we use to do forecasting. Okay, the first approach, if you remember, is called the knife approach. Okay, so I'm going to all this now. Knife approach, moving averages, exponential smoothing, and so forth. Now, knife approach is the simplest. You know what is knife, right? Knife. Knife means stupid, basically. Okay, knife means not based on anything. Okay, it's just naive. It's old school. Okay, old school of thoughts, stupid thoughts, naive approach, or traditional. Right? So if you use this kind of approach to do forecasting, what we do is we just assume demand in the next period is the same as demand in the most recent period. Right? For example, if I say if sales in January were 68 units, then what is the forecast of February? Okay, forecast for sales in February will also be 68. Okay, so that is naive approach. Or if I ask you, what is the customer demand that you forecast in 2023? Okay, if the actual demand in 2022 is 1,000 units, then the answer is same, same with previous years. Right? So that is naive approach. It's the simplest. You just assume that demand in the period that you want to forecast is the same as the demand in the most recent period. Right, so the second approach is called moving average method. Okay, now moving average is a series of arithmetic means you have to calculate the arithmetic means. There are two types of means. One is a geometric means, the other is called arithmetic mean. Okay, you can Google search. What are the differences between arithmetic means and geometric mean? Okay, in this method, we are calculating the arithmetic means. This method is used if there is little trend or no trend in the data, right? And this is the formula to calculate the moving average value. Okay, now moving average value is the forecast value. Just remember that. Okay, the question always asks you to calculate the moving average value. So that moving average value is actually the value that you want to forecast. It's the forecast value or it's the demand forecast value. So the forecast value or the moving average value is equal to the summation of demand in previous n periods divided by n. N is the number of periods. Right? So simple, right? This equation is just calculating the mean, right? This is the formula for calculating the arithmetic mean. Okay, is the demand in n periods. You total up all the demands and then you divide by n. So this will give you the mean. Okay, let's look at one simple example. Okay, how we apply moving average. Okay, let's say you forget about all these value first. Right? Let's say you're given the sales data, the actual sales, the actual demand. I already said demand equals to sales. Okay, let's say you're given the actual sales or demand data for January, February, and March. So in January, the sales is 10 units. February, the actual sales is 12 units. March, the demand is 13 units. Right? So these are actual. It has really happened. Right? Okay, so now let's say you are at the end of March. You want to forecast what is the demand in April. Okay, let's say you are now at the end of March. You want to forecast what is the demand in April. Okay, so if the question asks you to calculate the demand in April using a 3-month moving average. Okay, a 3-month moving average. So it means you take the average value of the most recent previous 3 months. Understand? It's simple, right? So let's say I'm at the end of March. I want to predict or forecast for April using a 3-month moving average. Then I will take the latest 3 months and I calculate the average. So I take 13, which is the sales in March, plus 12, which is the sales in February, plus 10, which is the sales in January. Okay, I total up, I divide by 3. Okay, so this is the average value, and the forecast value is 11 point something, 11, and then 2 per 3. So this is the forecast value in April. Right? So now, let's say now you're already in April. Okay, April has already passed. Okay, so once April passed, you will know the actual demand, right? And let's say the actual demand in April is 16. Okay, now of course, what happened in reality, the actual demand is different from what you forecast. Okay, it's totally acceptable. Okay, the actual demand given in this question is 16. This is actually what happens. But what you have forecasted before that is 11 point something. Right? So similarly, you can repeat this process. So if let's say now you're already at the end of April. Okay, you already know the actual sales for April and you want to forecast for May. Okay, you want to forecast for May. What is the sales for May? Using a 3-month moving average, then what you do? Calculate the average demand of the latest 3 months. Right? So to forecast the demand for May, you just use 16, which is the demand, the actual demand in April, plus 13, which is the actual demand in March, plus 12, which is the actual demand in February. Total up, you divide by 3, you get 13 point something. So this is the forecast value for May. Okay, understand? So let's say now May has already passed. Okay, once May pass, we will know the actual demand, and let's say the actual demand is 19. So with that, I can proceed to forecast for June. Okay, and the process can be repeated. So that's why it's called moving average. Okay, because the thing can keep moving. Okay, you can keep calculating it for all the coming months, provided you know the actual value. Okay, now please understand the value on the left here are the actual value, the actual sales, the actual demand value. The one you calculated on the right here are the forecast value. Right? So this equation is applied to the actual value, actual demand value. So you have to calculate the moving average for the actual demand value, not the forecast value. You don't go and calculate the average of the forecast value. You have to calculate the average of the actual demand value based on how many period that the question mentioned. Okay, so in the question, this question says 3-month moving average. So I take a 3-month moving average. Okay, but if 4 months, it's the same. So if 4-month moving average, then it means that you will need at least, you will need to have at least four actual demand data before you can calculate a 4-month moving average. Understand? So let's say now the question gives you these 4 sets of data, 10, 12, 13, 16. You're at the end of April. The question asks you to forecast the demand for May using a 4-month average. Okay, 4-month moving average. Okay, then how do you do it? It's just 12 plus 13 plus 16 is just 10. 10 plus 12 plus 13 plus 16 and then divide by 4. Right, so that will give you the 4-month moving average value for May. Okay, any question? No question. Okay, no question. We take a break. Okay, we'll take a break. 5 minutes break. Okay, come at 11:55 or 56. Okay, and then I'll continue from there. Okay, hope you all are back from the break. I can continue, right? Right, so let's move on to the next method. Next method is called weighted moving average. Okay, it's also like moving average, but it takes into account weightage or weights. Okay, it's normally used when some trend might be present, and you will find that older data are actually less important, so meaning that newer data are more important, right? Older data are obsolete, considered obsolete, so they have less relevance, but newer data are more relevant, so means they're more important lah. So weighted moving average is calculated using this formula. So understand, whenever I say weighted moving average value, so it means that is the forecast value. You try to forecast something using the weighted moving average value. So calculating the weighted moving average value will give you the forecast value. Okay, so it's calculated using this formula. You need the weights, okay, weights of demand in each period times the demand in that period, total up the summation, okay, and then you divide back the total. You divide back by the total weight. Okay, maybe I explain this to you first. Okay, you look back at the moving average example. Okay, you are given the sales data 10, 12, 13. Okay, and we assume that these three sets data are equally relevant. Okay, we are assuming if you use moving average, just the moving average, we are assuming that all the data are equally relevant because no weightage is given to the data. We don't assign any weights to the data. Okay, so we are assuming that 13 is equally relevant as 12. 12 is also equally relevant as 10. Okay, but this is not good. This is not actually very good because we know that older data actually are less relevant. Okay, so the data in January could be already less relevant compared to the data in March, which is the newer data, which is more relevant. Right? Because of that, we can actually assign weights or weightage to the data here to reflect their degree of relevance. So this is where the idea of assigning weights come into place. So normally older data will be assigned less weight, smaller weightage, because they are less important. And newer data will be assigned greater weights because they are more relevant. Right? So once we have assigned the weights, then we can calculate the weighted moving average using this formula. Here the weights times demand, you total up everything, divide back by the total weights. So let's look at this. Okay, basically it's the same example. So let's say you are given the actual sales data for 3 months. For 3 months, January, February, March. Okay, so you have 10, 12, 13. Okay, and let's say the question says this weightage will be applied 3 to 1. Okay, you can apply any weightage, no problem. Okay, the weights can be 3 to 1, it could be 10, okay, 5, 0, it could be 100, 70, 80. Okay, it doesn't matter. Doesn't matter why, because later you have to divide back by the summation of the weights. Okay, so these weights in exam will be given. Okay, we will give you the weight. Okay, the weightage to be applied. In practice, as I said, you're free to use any scale that you want. Okay, use any scaling for the weights that you want. Between 1 to 10, 1 to 5, between 1 to 100. Okay, any numbers that you see fit to be used. Okay, so according to this question, this scale of weights will be used. Okay, weights of 3 is for data which is the last month. Okay, a weightage of 2 is used for 2 months ago data. A weightage of 1 is used for 3 months ago data. Okay, so it means that 3-year will be assigned to March, data in March. Okay. And 2-year be assigned to February data, which is 2 months ago data. And 1 year will be assigned to January data, which is 3 months ago data. Okay, remember, we're trying to forecast April. We are now at the end of March. Here, we have 3 previous months actual sales data. We want to forecast the coming month, which is April. Right? So if you look back at that formula, weights times demand, and then summation divided by summation of weights. So what it means is just this. Okay, use the weights 3 multiplied with the demand in March 13. Okay, and then weights 2 multiplied with the demand in February, which is 12. Okay, and then weightage of 1, weightage of 1 multiplied with the demand in January, which is 10. You total up everything, then divide back by the summation of the weightage. Okay, summation of the weightage is 6. 3 plus 2 plus 1, 6. And that will give you the forecast value. Okay, so this is the forecast value. It is also known as the weighted moving average value. Okay, I hope understand. I hope everyone understand. Okay, so similarly, you can repeat the process. Forecast for May, for June, for July, for August, for September, until December. Okay, means this thing can keep moving. And that's why it's called a weighted moving average. Okay, if you understand, then let's move on. Okay, what is the problems with moving average? Either moving average or weighted moving average. Okay, the problem is with n. Okay, using the right n. Finding the right n is actually quite challenging. Because we can use 2 months moving average, or 4 months moving average, or 5 months moving average. So how many months of moving average you want to use? So what's the value of n? So setting n could be challenging. Now, if n is too big, let's say you set n equals to 6, 7, then it may smooth the forecast, but it will make it less sensitive to changes. Okay, and if n is smaller, then it's more sensitive to changes. Okay, so there's no exact way to set n. It all depends on the person who wants to forecast the demand. Okay, and generally, this method, moving average or weighted moving average, does not actually forecast trends very well because it fails to take into account trends. Okay, and this method, moving average or weighted moving average, requires a lot of data, as you have seen just now. You need a lot of historical data, okay, in order to do the forecasting. Which one is more accurate? I think you can answer. Is it using moving average is better or weighted moving average is better? Okay, I think you know the answer is weighted moving average will be better. Okay, because it use weightage to actually reflect the relevance of the data. Right, so this graph just shows which one is better. Okay, let's say y-axis is the demand, x-axis is the demand. The blue color is the actual sales. The blue color line is actual sales. The what color is this? Brown, orange. Okay, this orange brown color is the forecast generated by moving average, and the green color line is the forecast generated by the weighted moving average. So as you can see here, the green line is slightly closer to the blue line. right? Slightly closer to the blue line means more accurate because it's closer to the actual sales value. Right, so we can move on to the next method. Next method is called exponential smoothing. Okay. Now, this method is actually a form of weighted moving average. Okay, but not exactly moving average. Why? Because we don't have to bother about n. Okay, we don't have to bother about n. We just take the most recent month data and we make use of this smoothing constant called alpha. Okay, alpha is a smoothing constant. Okay, normally the value is between 0 to 1. Okay, the value ranges from 0 to 1 and is normally subjectively chosen. Okay, nobody knows what is the good or best alpha value to use. Normally it's subjectively chosen. So in exam, we will give you what is the value of alpha. Now the good thing about this method is you do not need to keep a lot of previous data because you only need to know the most recent previous month data or previous year data or previous week data. Okay, right, so this is the formula. So now formulas are starting to come in. So later there are more formulas. So this formula is used to calculate the forecast value. Okay, so the forecast value is equals to this formula is equals to the last period forecast value plus alpha. Alpha is the smoothing constant, and then multiplied with last period actual demand value minus last period forecast value. Okay, understand? So if I say what is the forecast value for this period? Is equals to the forecast value of last period plus alpha, which is a smoothing constant, and then multiplied with the actual demand value of last period minus forecast value of last period. Okay, got it? Okay, I put it another way. Okay, what is the forecast of February? Okay, let's say T is February. The forecast of February, okay, means okay, not February lah, maybe April. We are now in March, right? April. So we want to forecast April. So the forecast of April is actually equals to the forecast that we make in March plus alpha multiplied with the actual demand in March minus the forecast that we have made in March for March. Okay, hope you understand. Right, so this is one simple example. Let's say given predicted last period demand is 142 Ford Mustang, which is a model of Ford car, right? So last period, we have made the forecast. The forecast value was 142. Okay, and we also have the actual demand value of last period, which is 153 Ford Mustang car. And given smoothing constant is 0.2. Okay, so what is the forecast of this period?
144.2.
Okay, so this is the way as I did explain. So the forecast for this period or coming period equals to the forecast of the last period, which is 142 plus alpha, which is 0.2, multiplied with actual demand value in last period, which is 153, minus the forecast value you have made or that you have got in the last period, which is 142. Okay, so if you calculate and calculate, you get 144.2, which is roughly about 144 number of cars. Right? Okay. So just now I said alpha is between 0 to 1. It can be between 0 to 1. But generally, people will set it somewhere between 0.05 until 0.5. Okay, so that is the recommended value by the textbook. Smoothing constant is generally between this value, 0.05 and 0. Now, what is the impact of different alpha value on the forecast? Okay, so this is it. If alpha is bigger, if alpha increases, then you will find that older values become less significant. Okay, so in other words, if alpha is big or if alpha increases, newer value become more significant. Okay, this is what I'm trying to say. If alpha increases, older value become less significant, so it means newer value become more significant. Okay, so how do we choose the right value to use? This is the guidance. Okay. Okay, choose a high value of alpha. Okay, if you think that the average demand is likely to change. Okay, and choose a low value of alpha if you think that the average demand is quite stable. Okay, this graph illustrates what I said just now. X-axis is the time period, y-axis is the demand, the blue color line is the actual demand. So you can see the actual demand actually fluctuates, go down and then go up again, go down. Means the average changes really, the average changes. So let's say if you use alpha equals to 0.5 to make the forecast, then you will get the green line. Okay, so you see the green line, it is okay because it's quite sensitive to the change in the average value, right? But if you use alpha equals to 0.1, which is a smaller alpha, to make the forecast, you will get the forecast value like the orange line here. So this orange line value is the forecast value, say alpha equals 0.1. So as you can see, I think it's quite stagnant. So it means it is not sensitive to any change. Right? So the hint is this: choose high values of alpha if you think that the average demand is likely to change, and low values of alpha if you think that the average demand is stable. Okay, Hafizan left the meeting. Maybe internet connection. Okay, maybe let's do some questions first, to let you understand. Okay, I prepared this simple question. Okay, I give you 5 minutes to read it and also to solve it. Okay, only 5 minutes. Later I may call names. I may call names and hopefully you can tell me tell me the answer. Like you tell the answer, at least tell me how to solve it. Right? Okay, so please take 5 minutes to read this question and solve all the questions. Okay, let's discuss. Okay, the question says sales of hair dryers at the family store over the past 4 months have been 100 units, 110 units, 120, and 130 units. Okay, with 130 being the most recent sales. Okay, so it means the most recent one is 130, followed by 120, 110, and 100. Right, clear? So first question A, forecast demand for next month means the coming month using a 3-month moving average. Okay, anyone, any volunteer would like to just say it out? How do I calculate this forecast for the next month using a 3-month moving average?
Doctor, we just added 110 and 120 and 130 and divided by 3.
Okay, good, very good. So you take the most recent 3 months, given
Yes.
4 months data, right? So you have to take the most recent 3 months. So you take 130 plus 120 plus 110. Okay, this whole thing you total up, divide by 3, yeah? Okay, so answer, you get it yourself, I don't have the answer. I just prepared the question and I show you how to solve it. So you calculate it, the answer. Okay, next, B, forecast the demand for next month using a 4-month moving average. Okay, so instead of 3-month moving average, the question say now 4-month moving average. Okay, Amiro, give me the answer, 100, 110, 120, 130, divided by 415. Okay, so everyone can refer to the chat, So 115, Okay, 115. Next, question C, forecast the demand for next month using a weighted 4-month moving average with a weight of 4, 3, 2, and 1 respectively. Okay, any volunteer for this? Okay, Faiz say 100. Okay, let's look at the chat. There are two different versions. Huh? Everyone look at the chat. There are two different versions, I think. Same version. Okay, same. Okay, same. Huh? Right, so now we make use of the weightage. Remember, the higher weightage is normally assigned to the most recent data. Okay, because they are more relevant. And lower weightage are assigned to older data because they are less relevant. So you know, well, now, even though the question didn't say which weight has to be assigned to which month, you should know, huh? So weight of 4 should be assigned to the most recent data, which is 130. Okay, and then the next weight, which is 3, yeah, should be assigned to the second most recent data, which is 120. Yeah, and then the weightage of 2 should be assigned to 110. And 1 should be assigned to 100. Okay, so you have to total up all this. Okay, I changed my computer, so I'm not familiar with all the keyboards. Okay, and you have to divide back with the summation of the weights, summation of the weightage, which is 10, right? So the answer that is given in the chat, yeah, correct. If you divide by 10, the total divided by 10, okay. Okay, good. So it shows that everyone understand, So forecasting is not difficult, it means. Okay, hopefully later part also you can understand. Okay, for question D, forecast the demand for next month using exponential smoothing with alpha equals to 0.4. Given that the forecasted demand in the most recent month is 135 units. Okay, let's see the chat. Okay, Abdul Rahman say 135 plus 0.4, 130 minus 135. Alright, is that correct? Okay, Muhammad Faid, slightly different. Say 130 plus 0.4, 135 minus 130. So which one is correct? Abdul Rahman is correct or Muhammad Faid is correct? Oh, Rezwan give another one, which is 135 plus 0.4. Okay, so let's look at it. So remember, all these data given here are the actual sales data, actual demand. Okay, so you already have the actual, you have the forecast for the coming month, given alpha is 0.4, and given the forecast of the most previous month is 135. Okay, so the forecast of the coming month is equals to the forecast of the previous month, which is 135. Okay, plus alpha, which is 0.4, and then multiply with the actual demand in the previous period. Actual demand in the previous period is 130. So 130 minus forecast demand in the recent period, which is 135. Okay, so this should be the right answer. So answer is 1, 3, 3, yeah? 1, 3, 3. So I think Abdul Rahman is correct. I think 5 make the errors are confused. So don't get confused. So lessons learned for everyone. Okay, so don't get confused. It's last period forecast. Okay, plus alpha multiplied with last period actual demand minus last period forecast. Okay, and last one. If next month sales if next month sales turn out to be 140 units. Okay, so this is actual sales. If next month's sales turn out to be 140 units, forecast the following month's demand using a 4-month moving average. Okay, so I think everyone got it. So the chat 110 plus 120 plus 130 plus 140 divided by 4. Okay, which is 125. Okay, so correct lah. So it means you have to take now the most recent 4 months, which is this data 110, 120, 130 together with 140. Total up them, divide by 4. Okay, good. So I can see that you have no problem understanding these 3 methods. Okay, let's continue. Let's continue. Okay, how do we choose alpha? Okay, as I said, it's very hard to choose alpha. So normally what people do is they can use certain alpha value and do the forecast. And then they set another alpha value and they do the forecast. And then they compare which alpha value gives us a more accurate forecast. Alright, so how do we compare which one is more accurate? We can calculate the forecast error. Okay, you know error is equals to actual minus forecast. Right, that will give us the error. Now, this calculation of error is also very useful. For example, if you want to compare which method is more accurate. Okay, just now you have learned 4 methods, right? Naive approach, moving average, weighted moving average, exponential smoothing. Right, so you can apply these 4 methods, do the forecast, and then see which one is more accurate. Okay, how to see which one is more accurate? You compare the error. Okay, got it, Okay, but now we are looking at which alpha is better. So it means now we will use alpha to make the forecast. Okay, let's say 2 sets of different alpha to make the forecast, and then see which alpha value gives us a better forecast. Okay, got it? Right, now, just now I said calculating errors, right? Forecast error. Now, but this alone is not enough, because if you use this formula alone, sometimes your error can be positive, sometimes your error can be negative, right? Because actual minus forecast can be positive, can be negative. And if I total up, sometimes it becomes 0, right? Because positive plus negative will cancel the effect. Okay, understand, right? So instead of calculating the forecast error alone, we normally calculate 3 measures, 3 important measures, which is called MAD, okay, or GILA in Malay, but it's not GILA, it stands for mean absolute deviation, which is MAD. Okay, we can either calculate mean absolute deviation, okay, later I'll explain how to do this, or we can calculate mean squared error, MSE, okay, or we can also calculate MAPE, mean absolute percentage error. Okay, so let's go quickly how to calculate. I believe all of you have taken statistics. You should know how to calculate all this. Okay, let's start with calculating MAD, mean absolute deviation, MAD. Okay, so you with the name, you should know how it works. We have to calculate mean absolute deviation. Okay, what is deviation? Deviation is the error, is the difference. right? So it's the actual minus forecast. Okay, but it has to be absolute. So it means we take the absolute value. Okay, absolute value will ensure that all the values are positive. Right? So it means we calculate the absolute deviation. After that, we take the mean. Okay, how to take the mean? You total up, divide by n. So that will give you the mean absolute deviation. Okay. So now, let's say we have used 2 alpha. Okay, we are using exponential smoothing, but we are trying to compare which alpha is better. Okay, so the first alpha used is 0.1. The second alpha used is 0.5. Okay, so I don't have to explain all this. So these are the forecasts made using alpha 0.1, and these are the forecasts made using alpha 0.5. Right, so how do I get 175.5? I think we already know is last period forecast, which is 175, plus alpha, and then bracket the actual demand value minus the actual demand value of last period minus the forecast value of last period. Okay, so I get 175.5. So I repeat the process. I can forecast it for 8 period. Okay, forget about period 9. Why? Because we don't really know the actual demand yet. Okay, so this data shows 8 periods data. It shows the actual demand of tonnage unloaded. So it's actual demand. Okay, and we make the forecast using 2 alpha value. Right, so we calculated the forecast already. So now we want to know whether this is better or this is better. Okay, so one of the way to know which one is better is to compute MAD, mean absolute deviation, and see which one gives us a smaller MAD or MAD. Right, so how to calculate MAD? I think very easy. Okay, so first calculate the absolute deviation first. Okay, so create a column, calculate the absolute deviation. Okay, absolute deviation is actual minus forecast. 180 minus 150, you get 5. Okay, and absolute, absolute means 5. And then for the second one is 168 minus 175.5. Okay, and because absolute, you get positive 7.5. 168 minus will become negative, but because absolute, get positive, so 7.5. Okay, so you repeat the process, you calculate all the absolute deviation for the 8 periods of data. Okay, and then you total up, you get this value, then divide by 8, because we want to know the mean, right? So 82.45 divided by 8 to give us the mean absolute deviation, which is 10.31. Okay, understand? And do the same for alpha equals 0.5. First, create a column, calculate the absolute deviation first. So 180 minus 175 is 5. Then 168 minus 177.5 is negative 9.5. But because we are talking about absolute, so it becomes positive 9.5. Okay, and you repeat. And you get all the value, you total up. And then you divide by 8. Okay, and you get this. Okay, so these two values are the mean absolute deviation. Right? Okay, so if you understand mean absolute deviation, then let's move on to the second measure. Second measure is calculating mean squared error. Okay, now error is deviation, deviation is error. So don't get confused. Okay, I can call this mean squared deviation. same thing, or mean squared error. Right, so basically what you have to do is you have to calculate the error, which is the deviation, and then square them. Okay, how to calculate error? It's the actual value minus the forecast value. Right, so calculate the error and then square the error, because you want to get the mean. So it means you have to sum up everything and divide by n. Okay, so this will give us the mean squared error. So example, okay, just for simplicity, we show you only for alpha equals to 0.1. Alpha equals to 0.5, no need to show already, I don't want to waste space. So I will show you the alpha equals to 0.1. You do the same for alpha equals to 0.5. Okay, so same set of data, but we want to calculate mean squared error. So create a column, calculate the squared error first. Okay, so calculate the error. Error is actual minus forecast. So 180 minus 175, you get 5. Okay, but we are interested in squared, right? Squared error. So we squared the error, it becomes 25. Okay, same thing for the next data. We use the actual minus forecast, give us the error, which is negative 7.5, but we have to square it. So square it, you get 56.25. Okay, and you repeat everything. Once you get everything, you total up, you get this. So this is the sum of squared errors. Okay, but we are interested in the mean of square errors. So what you have to do, you have to divide by 8. So this will give us the mean squared error, which is 190.8. Right, understand? No problem. Okay, next measure is called mean absolute percentage error, which is MAPE. MAPE. So you read this, even though you don't know the formula, I think you should be able to calculate mean absolute percentage of error, mean absolute percent error. So it means what? First, you have to calculate absolute error first. You have to calculate the error, but make it absolute. Calculate the absolute error. So this is where you have this. Calculate the absolute error first. Error is calculated as actual minus forecast. We take the absolute value, so absolute error. But it wants to be in percentage. So how to turn it into percentage? You have to divide back with actual, and then times 100. That will turn it into percentage. Right? And then further you have to take the mean. So it means to total up everything, divide by n. Okay? So example, same set of data. Okay, we only show you alpha equals to 0.1. So how do we calculate MAPE? First, calculate the absolute error. Okay, calculate the absolute error. 80 minus 175, you get 5. Okay, but you have to convert it into percentage. How to convert it into percentage? You have to divide back by the actual value, which is 180, and then times 100. So this will turn it into percentage. Okay, so same thing for the second data. Calculate the absolute error first. 168 minus 175.5. You get negative 7.5, but because absolute, it becomes positive, so 7.5. Turn it into percentage, you divide back by the actual value, which is 168, and then times 100. This will become percentage. Okay, repeat for all the data, and you get the summation. Summation of absolute percentage of errors. Okay, but we need the mean, mean. So what do? We divide by number of data sets we have, we divide by 8. You get this. Okay, so very simple. If you really understand the concept Okay, so my advice to you is don't have to memorize the formula. Just look at the name. You should know what to do. Okay, so these are the summary. Okay, remember we're trying to find out which one is more accurate. We have make the forecast using exponential smoothing, one with alpha 0.1, the other with alpha equals to 0.5. Right? So we have calculated, first thing is the MAD value. So for MAD, you see when alpha is 0.1, MAD is 10.31, when alpha is 0.5, MAD is 12.33. So which one is more accurate? Smaller value is more accurate or larger value is more accurate? Small. Okay, correct. So it means alpha equals to 0.1 is better. Next, we also calculated MSE. So for alpha 0.1, MSE is 190.82. For alpha is 0.5, MSE is 195.24. So smaller is better, means this one is better. And lastly, we have also calculated MAPE, mean absolute percent error. Okay, so which one is better? Obviously, smaller is better. Again, so it means alpha equals to 0.1 is better. Okay, okay. So that's it. This is the comparison, okay, between two different alpha using MAD, MSE, and MAPE. Okay, that's what I already said. Sometimes you can also use it to compare different forecasting techniques. Okay, for example, one we use naive approach. Next one we use moving average. Next one we use weighted moving average. Then exponential smoothing. We can compare all these four methods and see which one is more accurate by calculating the MAD, MSE, and MAPE. Okay, okay, 12:45 already. So I think I should stop here lah. In this question, I think all you know how to do. Anyway, I will upload this to e-learning. Okay, so if you're hardworking, you can just do it. Okay, you can just do this and you can share your answer in the e-learning. Okay, I will not create assignment. Okay, I'm not sure you're familiar with e-learning or not. If I create an assignment module, it means you have to submit the assignment, just like tests or exams. Okay, but if you just want to share your answer, normally I will create a forum. Okay, I will create a discussion forum in e-learning system. So it means it's not compulsory for you to submit, but if you want to share your answer or discuss anything, you can just upload your answer in the discussion forum. Okay, so I think that is better. So upload this in e-learning. Those that are hardworking, okay, can solve it. And if you want to share your answer, you can share it through the discussion forum in the e-learning system. Okay, I think this is also very simple. Okay, but it's just to test your understanding lah. Right, okay, so I think we can stop here. Any question that you would like to ask?